Questions? Nothing?
Farming, at present time, salmon farming, finding at the base of the salmon farms, beds are now becoming contaminated, bacteria and many others. So the life of that seabed is now becoming dead. Now, can EM be either fed through the meal through the fish, or should it be fed some other means like your clay walls?
Right. Now, are they is these salmon farms, or fish farms, large ponds or?
They're contained in...
Contained, right.
Yeah.
You can do it both ways. One is to get the clay balls into the system. That is the best way of getting EM into the sludge. And there's enough examples from places like even Malaysia, Thailand, and even some of the trout farms in Europe, where they have used these mud balls to get the EM directly into the sludge to promote microbial activity. That is one. The second is to feed it. Both ways are possible, but if you want sludge breakdown to take place quickly, clay balls would be the best bet.
There's a mechanical way of making those clay balls. Oh, you've got that mechanical manufacturing.
It's they're mainly made by hand, but some of the countries that have made large quantities have got out into the community and got schools, clubs, disabled people, doing this. So, but there is I understand there has been a machine developed in Malaysia.
Malaysia, yes, and Thailand.
For about 30,000 US. So not cheap.
Yeah, it's these clay balls are made as a community activity in the development in places like Malaysia and things, where they get the handicapped children to do something for the environment. I was in Johor just before I came here, because EM Research Organization opened a shop, and we went to a handicapped school run by the Kiwanis. And there are 40 children, and the children are not called handicapped, they are called with special talents, and they are taught to put their food waste into a basket, make the little compost in the kitchen, take it out, mix it into the gardens, then get the material, make this bokashi or the compost, make it into mud balls, and there are people who are prepared to buy these mud balls. So they're doing something for humanity, and children and this is something that is now popular in Japan, Thailand, Malaysia, all those countries. It's very popular, and it's a community. It has given it into a more sort of a community activity that we are saving the environment. But otherwise, with the demand that we have in Thailand, we had to have a machine that was developed to make this.
So if the EM was put into the meal fish, would that have any effect? I mean, we're talking, and I think I'm hearing, but this was about 2,000 hectares ago involved in commercial fish farming. So,
yeah, it can go in.
Balls for that would be...
Yeah, not totally. The feed, the recommendation is that you take the normal feed, ferment it with EM, and add 10% of that fermented material into the normal meal. And that will get the EM through the system. You might find that the fish would grow faster, bigger, and some of the effects would go into the water and with the fecal matter. But the process will be slower than in breaking down the sludge, because there is contamination of EM when it goes through the gut of the fish anyway. So the microbial population that you would need will be lower if you feed it and it goes through the gut without getting it into. And we are talking about, at the beginning, the recommendation is 1 mud ball, good, well-made mud ball per square meter of land area. That's what we are talking about. Yes?
For parachute production, what would be the minimum quantity of EM1 be heat there, and what will be the maximum?
Mike, you correct me in this. Pastures
Pasture.
in New Zealand.
So the EM1 can be activated or expanded to make 1 litre of EM1 can be activated to make 20 litres of the expanded product. So it goes 1 to 20 in expansion. So we would recommend, depending on the situation on pasture, somewhere between 5 and 20 litres per hectare of the activated. So if it was 20 litres, which is our top rate, and we'd be putting, if we were wanting to break down stubble and really put a large population of microbes onto the pasture and soil, we'd put 20 litres on, which comes back to 1 litre of EM1. Okay, so 1 litre of EM1 activated to 20, and then that goes on per hectare.
So 5 litres will be lower.
If we're putting on some other products like say liquid fish or seaweed or other liquid fertilisers, then we could go down as low as 5 litres combined with that. But it just depends what you're targeting. You know what you're targeting. If you want to get maximum microbes on the ground, then we're up to 20 litres. If we want to enhance fertiliser activity and so on, and we're putting it with fertilisers like fish and seaweed, down to 5.
We had a slide about Chernobyl there. What you flashed past, what was happening? Was it actually cleaning up the ground?
Yeah, they are using organic matter and EM and growing vegetables. Earlier they used the, at the beginning how they started in Chernobyl was to grow, apply EM organic and organic matter and grow plants. And they found that the amount of radioactive material in the plants was fine. And they took all away and burnt it to decontaminate. Now that the contamination is lower, they are growing vegetables. And they find that the ones with EM have a lesser amount of radioactive material.
You mentioned the toxic effects of using animal manures. Can you tell us a bit more about that?
Right. Now, enough research has shown that excessive animal manures onto a pasture can cause contamination in terms of toxicity in terms of heavy metals and things. And if you, there is enough published literature on this. If you compost it and then put it, you would reduce those, and to get a good quality animal manure compost in a short period of time, this is where EM comes in.
So that's aerobic composting?
Yeah, aerobic or anaerobic. Aerobic might take a bit longer, anaerobic would be faster because it can contain the temperature and the process. Yeah. Now in things like landfill or green waste, you can't have anaerobic, it's very difficult. Now I know in Austria, one of the biggest problems that the city of Vienna had was to get rid of their horse manure. Because in Vienna, in the old city, there are horse carriages taking tourists around. And the manure was a problem for the city council. And just outside Vienna, 20 kilometers away, there is an organic farm certified by IFOM. And the farmer is laughing all the way to the bank because the city council pays him to remove his organic matter and the waste from the markets of Vienna. He makes it into a beautiful compost, uses it on the farm, and sells the product back to Vienna. No smell when they do aerobic composting. So because it's large quantities, they mix straw, wheat straw into it, and they bring all the vegetables, leftovers, and rotten onions and potatoes and things in this composting, and it is made into a good quality compost that goes back into a farm, and they produce good quality hops. They have organic beer and even an organic restaurant where you have to book on a Tuesday or Wednesday to get a seat to have a meal on Saturday and Sunday. And they use EM because otherwise the people around will complain because of the smell.
Does EM promote earthworm activity?
Earthworm activity.
Yes, certainly yes. Yeah, yeah.
So
And also some even, have you heard of the Earth University in Costa Rica? VHU hasn't heard of Earth University. It's a university funded by the Rockefeller Foundation in Costa Rica, which teaches only organic farming, sustainable agriculture. They take in 100 students, 90% of them are on scholarships, and they teach them. And EM is a part of their curriculum. And there, all the worm farms get EM because it promotes the vermicomposting much better, and it promotes the growth of the earthworms.
With your dilution rates, do you have an idea of what the multiplication factor of the organisms can be?
Yeah, you can go up to a million times with actification. Dilution. Depends on what you want to use it for. If you want a concentrated solution, the advocated dilution of 1:100, right? 1:50. What do you advocate here in other New Zealand conditions?
It's often 1:100, depending on the situation. If it's going into a compost, you might be diluting at 1:1,000 because you want to get water, you want to get penetration into the compost. If you're going onto a crop that you want to get a good population over the leaf surface, like kiwi fruit or grapevines, you'll do a 1:100, so 1%.
Yeah.
So is that the activated or the concentrate?
Activated, yeah. Basically, with the activated concentrate, you treat them basically the same. So if you're using activated, then if you're using the concentrate, which some people in the home garden just use the concentrate because they have a 1 litre bottle, and if you diluted that 1:100 or 1:1,000, that bottle's going to last a long time in the home garden, so they just don't bother doing the activation. So we say you dilute it 1:100 and use it, and then if it becomes activated, you treat it the same as the original. You dilute it at 1:100 or 1:1,000.
So the microbial population also will be diluted to about 1/10 of its concentration in the soil position.
And so what would be the advantages of applying EM on a foliar application?
As a foliar application, we believe it does its most important job in the. Yeah, I think the key principle, I think, is that it's not providing all the microbes that need to make that soil go, but it's stimulating as much as it's providing some key microbes. But I mean, if we looked at all the microbes in the soil, I mean, EM's this much of, I mean, it's only, there are thousands of species in the soil. But as Ravi said, I think the key thing is there's a big chunk of those are neutral and they'll swing one way or the other. And then pathogens are a small number, and we can influence. So the EM has an influencing, stimulating effect, more so than supplying all the microbes necessary. And the other thing is that we always say, we've got to have organic matter. Organic matter is the food for the microbes. And if you put bacteria and organic matter together, you get fungi, and you get protozoa, and you get all of these other things. But things happen in succession in the microbial world, right up to the earthworms. So your earthworms will be promoted with bacteria, fungi, protozoa, and so on. Any other questions?
Has there ever been any research done on animal health, livestock?
Yes.
Is
From
there,
Europe. He's from Europe. Yeah.
is there data available to?
Yeah. I think it's available. Yeah. We might be able to get that across to you. I'll get that to you.
The animal one, there's, as you know, the Bokashi bucket system, which has the Bokashi in it, and that's a fermented, it's taking the EM there and fermenting organic matter. When you do that, you don't just get organic matter plus microbes, you get other products being produced. So when you put those two together, you get the production of a whole lot of other substances. And it's a bit like if you take grass and then you put it into a silage heap. So you've got, in the silage heap you've got grass plus other substances which occur in the silage process. So that's a bit the same with EM. You put EM into organic matter and you get a secondary process with these other products which are being produced. And some of those are like this antioxidants, but you've got vitamins, you've got growth promoting substances, and you know, many other things. So with the animal side of things, they found that by producing a feed Bokashi and feeding that to the animals, they get a benefit in the animal health and the growth of the feed conversion factor and the health and growth of the animal. So the feed Bokashi is quite important in that scenario. And we don't currently have any commercial feed grown with EM in New Zealand, but it's something that we look